I'm very Swarna working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on characteristic function and moment generating function. So in the previous lecture, already have finished the topic characteristic function as well as a moment generating function. For example, if you have a random variable x, then the characteristic function of that random variable has been defined by pi x of omega equals to expectation of e power j omega x. Now what's the problem here? Find the moment generating function and characteristic function of the random variable x which has uniform distribution. Okay. So what is the characteristic function of random variable? How it is defined? Pi x of omega equals to expectation of e power j omega x. And what is the moment generating function? Which has been defined by what? Mx of u, or can take it as mx of v. Nothing but expectation of e power u into x. So this is called as what? Characteristic function, and it is called as what? Moment generating function. And moreover, what they are given here? We have to calculate the moment generating function and characteristic function of the random variable x which has uniform distribution. It means what type of random variable they have given? The type of random variable they have given is what? Uniform random variable. And the uniform random variable is a standard random variable which is of continuous random variable. And what is the density function of the uniform random variable, which we have already finished in the previous topic? Then has been given by fx of x is equals to 1 by b minus a when x is a to b and 0 otherwise. So why it is called as uniform distribution? So when x is from a to b, the distribution is constant over this interval. That's why this is called as what? Uniform distribution. This is called as what? Uniform random variable. Now we have to calculate what? Moment generating function. After that we have to calculate the characteristic function. So what is a moment generating function? That has been given by what? Pi x of omega is equals to expectation of e power j omega into x. So what is the expectation of any random variable? That depends upon the type of random variable. If the random variable is of continuous type, the expectation of any function is what? Integration. Since you have a single random variable, we are going to get a single integration. So integration minus into infinity, x is from minus into infinity. So expectation of any function is nothing but that function, nothing but what? E power j omega x into the probability density function of that particular random variable, that is nothing but fx of x into dx. Now, what is fx of x of that uniform random variable? It has been given by what? 1 by b minus a when x is from a to b. Only in this interval it is 1 by b minus a, and outside of this interval it is equals to 0. Therefore, I can rewrite this interval as a to b. X is from a to b. So, e power j omega x into, and what is the density function of the uniform random variable in this interval? That equals to what? 1 by b minus a into dx. So that equals to 1 by b minus a into, what is the integration of e power j omega x? With respect to x, you have to do it. Therefore, that has been given by e power j omega x by j omega. And what are the limits of x here? That is from a to b. So this is nothing but what? Characteristic function. That equals to 1 by b minus a. And it's how integrate with respect to x. Therefore, in place of which variable you have to substitute the upper and lower limit, you have to substitute in place of x. So substitute the upper limit as b and minus substitute the upper limit as a. Then can obtain as e power j omega b minus e power j omega a by j omega. So therefore, this is nothing but what? The characteristic function of the uniform random variable. So what is that value? E power j omega b minus e power j omega a by j omega into b minus a. And one more thing, we have to calculate what? Moment generating function. So what is the moment generating function of a random variable x? which has been represented by what? Mx of u, or I can take it as mx of v also. It is nothing but what? Expectation of v power u into x. And what type of random variable x they have given? They have given it as a uniform random variable, and uniform random variable is a continuous random variable. Therefore, expectation of any continuous random variable, since you have only one random variable, I am getting only one integration, and the limits of x are from minus into infinity. The expectation of any function is so that function into the density function of that random variable, nothing but fx of x into dx. So that equals to, but what is fx of x for the uniform random variable? That equals to what? 1 by b minus a when x is a to b. So it is when x is a to b. So what is the density function, probability density function of that uniform random variable? 1 by b minus a. So into what? Dx. It equals to 1 by b minus a into, and what is the integration of e power ux with respect to x? That has been given by what? E power ux by u. And the limits are from a to b. Then substitute the upper and lower limit in place of x, because the integration with respect to x. That's why in place of x you have to substitute the upper and lower limits. Then you can obtain as what? E power u into, what is upper limit here? B minus e power u into a by u. So therefore this is what? Moment genetic function of the given uniform random variable and the characteristic function of that random variable which has been given. Therefore, the moment generating function of a uniform random variable which has been defined over the interval a comma b is given by mx of u is equals to what? E power ub minus e power ua by u into b minus a. So what is the answer you got here? E power u into b minus e power u into a by u into b minus a. And similarly, the characteristic function of a uniform random variable over the interval which has been distributed over the interval a comma b, which has been given by pi x of omega is equals to e power j omega b minus e power j omega a by j omega into b minus a. So like that, for the given random variable, you can calculate the moment genetic function as well as the characteristic function. And one more problem what they are given. The characteristic function of a random variable x is given by pi x of omega is equals to 1 by 1 minus j 2 omega into 2 omega power n by 2. Find the mean and second moments of x. So what they are given that? They have given the characteristic function. What is characteristic function they have given? Pi x of omega equals to what? 1 by 1 minus j 2 omega power n by 2. So this is a characteristic function of a random variable x has been given. What you have to calculate? You have to calculate the mean and second moments of the random variable x. So we have seen the properties of the characteristic function. So if the characteristic function of a random variable has been given, how to find out the nth moment of that random variable? So mn is equals to what? 1 by j power n d power n pi x of omega by d omega power n at omega equals to 0. So this is a formula what? If the characteristic function has been given, then in order to calculate the nth moment about the origin, this is the formula we are going to use. Now what you have to calculate? You have to calculate the mean. So what is the mean? Mean is nothing but what? The first problem is what? You have to calculate the mean of the random variable. So mean is nothing but what? M1 only. So what is the nth moment about the origin? How it is defined? Expectation of x power n is called as what? The nth moment about the origin. Now if n equals to 1, then what can you obtain? M1 is equals to what? Expectation of x power 1. there is nothing but what? U of x. Therefore, the first moment about the origin, which is called as what? The mean of the random variable. So, in order to calculate the mean of the random variable, from the characteristic function, you have to substitute n equals to 1 in this equation and then you have to calculate. Therefore, m1 are the mean. E of x is equals to what? 1 by j. So, d, you have to substitute in the previous formula in place of n as 1. So, d omega at omega equals to 0. So, that equals to what? 1 by j. So, d by d omega of, so what is the characteristic function they have given? They have given as what? 1 by 1 minus j 2 omega power n by 2. So, what they have given? So, in this you have to substitute n equals to 1 so that you are going to get the mean. So, the characteristic function they have given as what? 1 by 1 minus j 2 omega power n by 2. So, 1 by 1 minus j 2 omega whole power n by 2. So, after differentiating only, you have to substitute omega equals to 0. So, after differentiating, you have to substitute omega equals to 0. So, then equals to 1 by j d by d omega into, you can write this as what? 1 minus j 2 omega power minus n by 2. So, at omega equals to 0. That equals to 1 by j. So, what is the differentiation of 1 minus j 2 omega power minus n by 2 with respect to omega? So, what can you obtain here? So, minus 1 minus j 2 omega power minus n by 2 minus 1 into, so on the differentiation of this j 2 omega, so minus n by 2 into, so this is minus n by 2 into, and the differentiation of minus j 2 omega with respect to omega. So what can you obtain here? Into minus 2j. So that equals to, after that what you have to do, you have to substitute omega equals to 0. Then what can you obtain here? 1 by j into, if you substitute omega equals to 0, then what can you get here? 1 power minus n by 2 minus 1 into minus n by 2 into minus 2j. So here j will get cancelled. Then here 2 will get cancelled. Then what is going here? Minus n into minus n, nothing but n. And 1 power minus n by 2 minus 1, nothing but what? 1. Therefore, what is the mean of the random variable you got? You got the mean of the given random variable, you have got as what? N. And second one, what you have to calculate? You have to calculate the second order moment. Then it means you have to calculate m2. So what is m2 is nothing but u of x square. So from the characteristic function, how do you calculate the second moment about the origin? In this formula, how to substitute n equals to 2. Therefore, substitute here n equals to 2. Then what can you obtain here? 1 by j whole square into d square pi x of omega by d omega at omega equals to 0. So that equals to what? 1 by j whole square. So d by d omega into d pi x of omega by d omega at omega equals to 0. So that equals to what? 1 by j whole square d by d omega. And what is d by x of omega? Already had done one time. Then nothing but what? 1 minus j 2 omega. So what we got here? 1 minus j 2 omega power minus n by 2 minus 1 into minus n by 2 into minus 2j. So into what we got here? Minus n by 2 into minus 2j. So at omega equals to 0. So here 2 is get cancelled and minus n into minus, nothing but how can I write this as? So 1 by j square. What is j square value? Minus 1. So 1 by minus 1 into n into, and you have to differentiate this with respect to what? Omega. Then what can you obtain here? So minus n by 2 minus 1 into 1 minus j 2 omega power minus n by 2 minus 1 minus 1. Nothing but what can you obtain here? Minus n by 2 minus 2. And into the differentiation of minus j to omega is nothing with respect to omega. Nothing but minus 2j. After that, you have to substitute omega equals to 0. Then you can obtain as minus n into, now substitute omega equals to 0. So if you substitute omega equals 0, then what can you obtain? So minus n by 2 minus 1 into, so substitute omega equals 0. So this part becomes what? 1. So 1 power minus n by 2 minus 2 into minus 2j. So that equals to, and you have to differentiate for one more time. So minus 2j into minus 2j. So you are getting again minus 2j. So if you differentiate, previously got what here? J, n into j here. So here also n into j. And here n into minus nj into minus 2j. So you are going to get j into j nothing but j square. So then you are going to get here what? N into n by 2 plus 1. Therefore, what is a first order movement or the expectation or the mean of the random variable x got as what? N. And what is m2 got here? U of x square, nothing but the second movement about the origin. What is the answer you are going to get? So n into n by 2 plus 1. So like that, if they give the characteristic function, then you can calculate the mean and the nth movement of the random variable by using this formula. The next problem is what? Let the random variable x have the probability density function with fx of x equals to 1 by 2 into e power minus x by 2 for x greater than 0 and 0 otherwise. Find the moment density function and mean and about the mean and variance of the random variable x. So this is mean and you have to calculate what? The variance. So you have to calculate mean and the variance of x. So what they have given here? They have given as what? The density function. What is that value? 1 by 2 into e power minus x by 2 when x is greater than 0 and 0 otherwise. So what you have to calculate? You have to calculate what? The moment generating function. So what is the moment generating function of random variable x formula? Mx of u, moment generating function, that is a short notation, is equals to what? Expectation of e power u into x. And what type of random variable here it is? It is a continuous random variable. By observing this density function, you can say that it is a continuous random variable because for all the values of x it is defined. Therefore, the expectation of e power ux is what? Integration minus infinity e power ux into fx of x into dx. That equals to integration. And what is the density function? The limits x is greater than 0, nothing but for the limits of x here you have to replace it by 0 to infinity. So e power ux into fx of x. What is fx of x here? 1 by 2 into e power minus x by 2 into dx. For other values, nothing but from minus into 0 it is 0. So 0 into something you are going to get 0. Therefore, the limits of x have been replaced by 0 to infinity and the density function has been defined by 1 by 2 into e power minus x by 2. Now, take 1 by 2 outside, then you can write as what? E power integration 0 to infinity e power ux into e power minus x by 2 into dx. So that equals to 1 by 2 integration 0 to infinity e power u minus 1 by 2 into x. It means just you are taking the common as the variable x. So e power u minus 1 by 2 into x into dx. That equals to 1 by 2. And what is the integration of e power u minus 1 by 2 into x? Nothing but e power u minus 1 by 2 into x by u minus 1 by 2. And the limits are from where to where? The limits are from, x limits are from 0 to infinity. Now substitute the upper and lower limit. So if you substitute them, then you can write this e power u minus 1 by 2 x as what? Minus of minus u plus 1 by 2 into x by u minus 1 by 2 into 0 to infinity. So that equals to what can you obtain here? 1 by 2 into, if you substitute the upper limit, e power minus infinity. So minus e power 0 by, what you got here? U minus 1 by 2. So here you got u minus 1 by 2. Then that equals to what? 1 by 2 into e power minus infinity is 0. So minus 1 by u minus 1 by 2. So that equals to, so 1 by 2 into 1 by 2 minus u. That equals to 1 by 2 into, so if you take LCM, then what can you obtain here? 1 by 1 minus u by 2. 1 minus u into 2. That equals to what? The moment function mx of u is equals to what? 1 by 1 minus 2 into u. So like that you can calculate the moment function. Then what you have to calculate? You have to calculate the mean and variance. So from this moment function you have to calculate the mean and variance. So if you know the mean of the moment function of the random variable, then what is the nth moment about the origin formula? N is equals to what? D power n mx of u by du power n at u equals to 0. Now what is the mean? Mean is nothing but what? M1. So you have to calculate what is M1? D mx of u by du at u equals to 0. And what is the variance? So variance is nothing but what? M2 minus M1 square. So what is M2 is nothing but what? D square mx of u by du square minus, and already you have calculated M1 here. So just calculate, substitute and then substitute here. You can calculate the variance. Therefore, like that you can calculate the mean and variance by calculating what? The nth moment about the origin. What is the formula to calculate for that? N is equals to what? D power n mx of u by du power n. After differentiating, you have to substitute u equals to 0. So what can you obtain here? 1 by 1 minus 2u. How many times you differentiate this one? This you differentiate for n number of times. If you want the mean, then what is m1 is equals to d mx of u by du. Then what is that value? If I want to calculate, for example, mean, then what you have to do? D by du of 1 by 1 minus 2u at u equals to 0. So that equals to, then what can you obtain here? You can obtain as what? So differentiate for one number of time. Then what can you obtain here? Minus 1 by 1 minus 2u whole square into minus 2 at u equals to 0. Now you can obtain this as what? So 1 by, you have to substitute u equals to 0. Then what can you obtain here? Minus 1 by 1 square into minus, that equals to what? 2. So like that you calculate the mean, and similarly you can calculate M2. If you differentiate this for one more time, we are going to obtain M2. After differentiating, you have to substitute e equals 0. Then you have to calculate the variance, you have to use the formula what? M2 minus M1 square. So therefore, you can calculate for the given random variable x, you can calculate the moment function and characteristic function. That is one type of problems you are going to get. Another type of problems you are going as, they will give the moment function, characteristic function. You have to calculate the nth moment about the origin. Like you have to calculate the means, second order moments, variances like that. Then by using the corresponding formula, you can calculate the nth moment about the origin. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.